Hello mathematicians. Okay, you have been working on circles part 1. You did central angles, you did arc lengths, and now we're working on inscribed angles. Now, inscribed. Scribed means to write on, right? So inscribed. An inscribed angle is an angle with its vertex on the circle, right? Because it's written on the circle. And it has two sides that are chords. We've got two sides that are chords. So this is an inscribed angle. Now, an intercepted arc is the arc that lies between the endpoints of an inscribed angle. So I can go ahead and just highlight right here. This is my intercepted arc. Now, finally, some things that we need to know. The measure of an inscribed angle, so the measurement of this angle right here, of our inscribed angle, is equal to half the measure of its intercepted arc. So I've written that over here. If I have an arc AC, I know that the angle of ABC is going to be half of AC. So I have written this equation here to help me remember what to do while I work on some assignments today. Okay, intercepting a diameter. What does that mean? If an inscribed angle intercepts a diameter, then it is a right angle. So what that tells me is I know the measurement. So I would know that this is 90 degrees right there, right? Since my angle, my inscribed angle, see A is on the circle and its chords are coming out, and since they touch the diameter, they make a perfect right angle. Now, what does that mean? M and then that funny sign BAC. This means the measure of angle BAC. So I wrote that over here, the measure of angle BAC. Now that little M right there means measure. So we're going to be looking for when our inscribed angle touches both ends of the diameter, because then we already know something. It's 90 degrees here. And then finally, overlapping arcs. Overlapping means they're touching each other, like they're laying on top of each other. So I'm going to use two different color pens to help you see that today. Okay. So if two inscribed angles intercept the same arc, so they're sharing the same arc, then the angles are congruent. So I notice that I have angle, let's see, they want us to be working about A. So I notice that I have A here. So I have angle, oh, you know what, they want us to look at angle ABD. So let's go ahead and do that. So they want us to look at angle ABD. So they want us to see this one right here. So angle ABD. You see that? Angle ABD makes this arc right here. But if you also notice, so does ACD. ACD also has an arc of AD. So do you notice that this inscribed angle has the same arc as this inscribed angle? So that means that both of these angles right here are going to be equal to each other. So if whatever this measurement is, it's also that measurement. So when I have two, that's just going to be something else I can use to solve problems. Okay, let's go ahead and look at number 1. We'll start out easy and then I'll kind of skip around and get to some of the harder ones. Okay, so first of all, find each angle and arc measure. Okay, angles. So remember, if I know that this is 62 degrees, I know that my, right here, my angle WXY is going to be half of arc WY. Right? So WXY is going to be half of this number. Now, what is WY? Well, WY is 62. What is half of 62? Well, I'm just going to look here and go 62 and divide it by 2, because that tells me what half is. It's 31. So my angle measurement is 31 degrees. It always helps me to write the formula to help me figure it out. Okay, let's take a look at our next one. So notice in my next one, they want to know the measure of DGF. They want to know the measure of DGF. Well, I know this is half of this, right? So I know that arc DGF is going to equal to 2 times the angle DEF. And what is angle DEF? Well, angle DEF is 113, so I need 2 times 113. And what is 2 times 113? Well, 2 times 113 is 226. So my answer is 226 degrees. Because remember, this is always 2 times larger than this one, and this one is always half of this one. So however you need to think about it, use it to solve your problems. Okay, so I'm going to actually let you do, well, what is this? Angle PQR. What is the angle of PQR? Oh, that's going to be one of our practices. Okay, so let's see what we have going on here. So we are looking at PQR. So we've got PQR. Well, what do I notice about PQR? Well, the 2 chords are touching what? Look at where the chords are ending, just like we talked about up here. When they are touching a diameter, that means that this angle right here is 90 degrees. So I don't even have to do any calculations. I just had to remember our rule. If the 2 chords touch the ends of diameters, then this is automatically 90 degrees because it's a right angle. Okay, let's go ahead and take a look at, well, you know what? You're going to be ready to do number 4. And 5 and 6. So let me go ahead and jump to number 7. Work on these. If you do need help, I will come around and help you, but I do want you to take what you've learned up here because we've learned enough up here for you to be able to solve these. Okay, so let's go ahead and look at number 7. Again, I always kind of have to talk myself through and read everything. I do notice that I know this angle. I know CDE, and I know that CDE is an angle, and I know that I also have arc CE, which is 158. It's the intercepted arc. So I'm going to go ahead and write in my formula from up here and then plug in what I do know. So I do know that I have angle CDE is going to be equal to 1/2 of arc, the measure of arc CE, right? Well, what is the measure of arc CE? It's 158. So I'm going to take out the measure of CE, and I'm just going to put in 158. I want to know half of 58. But I notice that CDE also has an equation. That is 8x minus 9. So I have to do some simplifying here. So what is half of 158? Well, I'm going to take 158 and divide by 2. 79. Well, now, if you didn't remember that, you could do 1 divided by 2 times 158, and you still get 79. So now I have 8x minus 9 equals 79. Now, once we're here, we just have to solve. Remember, we have to isolate the x. Our goal is to get this all by itself. That's what we're looking for. So I am going to start undoing my problem here. I've got a -9. I want it to be 0, so I'm going to add 9. And then I'm going to add 9. And I'm going to get 88 equals 8x. Now, I want this to be a 1, so I'm going to divide by 8. It becomes a 1. I'm going to divide this by 8. And x equals 11. And we are done. And let's see. Let's go ahead.